Hi, I'm Teacher Thomas. Welcome to A-Level Maths. This is the specimen paper for 9231 Further Pure Mathematics 1 for the 2020 exam series, question 7. We're given the curve C. Requirements A, B, and C is where we'll begin. A, state the equations of the asymptotes of C. B, show that y is less than or equal to 25 over 12 at all points on C. And C, find the coordinates of any stationary points of C. For A, I'll evaluate for horizontal asymptotes by taking the coefficients of the highest degrees of the variable. So if I take just the x squared terms, 2x squared over x squared, which is the same as 1x squared, the fraction formed by the coefficients is 2 over 1, which equals 2, and my horizontal asymptote is y equals 2. To find the vertical asymptote, I'm going to look at what x values would result in a 0 value in the denominator. X squared minus 2x plus 1 equals 0. X simplifies to 1. In this function, no oblique asymptotes. Oblique asymptotes occur when the highest degree of the variable in the numerator is 1 greater than that in the denominator. In this example, we don't have that scenario. On to requirement B. I'll work with a discriminant evaluation to work through B. I will cross multiply to get on the left side y times x squared minus 2x plus 1 equals 2x squared minus 3x minus 2. When I distribute the y and move the right side terms to the left, I end up with quadratic in x, y minus 2x squared minus 2y minus 3x plus y plus 2 equals 0. I'm going to evaluate b squared minus 4ac. b is negative 2y minus 3. Notice there's a negative out front of the b term. So we'll have negative 2y minus 3 squared minus 4 times a is y minus 2 times c is y plus 2. I'm evaluating for y values greater than or equal to 0. When I simplify, I get to the inequality negative 12y is greater than or equal to negative 25. When I divide both sides by negative 12, because I'm dividing by a negative, my sign changes to less than or equal to, and we end up with y is less than or equal to 25 over 12. In C, looking for stationary points, I want the derivative of the function. I'll use the quotient rule. In the numerator I have function u, and the denominator I have function v, and with differentiation I end up with 4x minus 3 times x squared minus 2x plus 1, which is the derivative of u times v, minus 2x squared minus 3x minus 2 times 2x minus 2. This is u times the derivative of v over x squared minus 2x plus 1, which is v squared. When I'm looking for an output of 0, I can, for the moment, disregard the denominator. I'm only going to work with finding the x value or values that result in the numerator equaling 0. When I work through the algebra, I have two solutions, x equals 7 and x equals 1. Recall from part A, one of our asymptotes is x equals 1. If we hadn't done part A, because we have variable x in the denominator of the function, we need to check x equals 7, x equals 1. Does either of those result in a denominator of 0? Yes, x equals 1 does. So I've already identified x equals 1 is an asymptote, so that x doesn't apply. I'm simply working with x equals 7. And I want the coordinates, so the y value, the function when x equals 7, when I input 7 into the x's and simplify, I get 25 over 12. And my coordinates are 7, 25 over 12. The appearance of the same y values in part B and C isn't a coincidence. Both of these requirements relate to stationary points, and an alternative methodology for part B would be to use differential calculus. This completes the requirements for parts A, B, and C.